All right, in 6.5 part 2, we are going to take a look at solving trigonometric equations involving quadratics. In this first example, we already have a function that is factored for us. So if you remember, whenever we're solving a quadratic like this, we can just set each individual factor equal to 0. So I can say 2 sine of x minus 1 equals 0, and separately, 2 cosine of x minus square root of 2 equals 0. Then we'll just solve each of these equations separately, like we did in the last video. So I would add 1 and then divide by 2 here and get sine of x equals 1/2. Here I would add the square root of 2 and divide by 2 and get cosine of x equals square root of 2 over 2. Then we are using our unit circle to find where sine equals 1/2. Remember, sine is the y value, so that would occur here and here. So we can say that x is pi over 6 and 5 pi over 6. Now, remember we said technically we should add on the plus 2 pi n, but since this question only asks for values between 0 and 2 pi, I can clearly see if I'm at pi over 6 and I add 2 pi, I'll be outside of the 0 to 2 pi range. Okay, same thing with 5 pi over 6. So those are my only two answers here. Then for cosine, I want to see where cosine is the square root of 2 over 2. Cosine is the x value on the unit circle, so that would occur here and here. So pi over 4 and 7 pi over 4. Okay, and for the same reason, right, if I were to add 2 pi, I would be outside of this 0 to 2 pi range. Okay, so this equation, this function, has 4 solutions. Pi over 6, 5 pi over 6, pi over 4, and 7 pi over 4. All right? So let's look at an example now that is not factored for us. Okay? 2 sine squared minus 5 sine plus 2. If we come across something like this, we want to treat it just as we would any quadratic, right? We could even just think about this as being 2x squared minus 5x plus 2 equals 0. Right? We're just thinking about the trig function as the variable. So I want to factor this quadratic, right? To do that, we would want to factor by grouping. So a times c, 2 times 2 is 4, b is negative 5. So two values that multiply to positive 4 that adds a negative 5 would be negative 1 and negative 4. So we would need to factor by grouping here. So we'll have 2x squared minus x minus 4x plus 2 equals 0. Group the first two, group the second two, take out a GCF, so I can take an x out here. I'd be left with 2x minus 1. Here I can take a negative 2 out, and I would be left with, I'd be left with 2x minus 1 if I take a negative 2 out. And then to finish, this would just be 2x minus 1 times x minus 2. So that's where we would pick up here, okay? This would factor into 2 sine of theta minus 1 times sine of theta minus 2. Okay, when we did this factoring, all we did was replace sine with x. We did our factoring, right, and came up with 2x minus 1 times x minus 2. So if I put the sine back in for x, this is what my original equation would look like factored. Now we can do the same thing we did in the first example. Set each individual factor equal to 0. So 2 sine of theta minus 1 equals 0. And sine of theta minus 2 equals 0. here, I would add 1, divide by 2, get sine of theta equals 1/2. Here, add the 2 over, and I'll get sine of theta equals 2. So here, on the unit circle, looking for where sine is 1/2, so that ends up being the same as the first example, right? We get pi over 6 and 5 pi over 6. And again, we're just looking for the values in between 0 and 2 pi on this example, so I do not need to tack on the plus 2 pi n. Then my second piece here is sine of theta equals 2. Well, one thing that we need to remember, right, is the maximum value for sine is 1, and the minimum value for sine is -1. There is no angle for which sine of theta equals 2. Okay? This yields no answers. This yields no solutions. Okay? So in this case, for this problem, these are my only two answers. Okay? One of my factors, the sine of theta equals 2, doesn't give me any answers, right? Because what it's equal to is outside of -1 to 1, right? The range of sine, right? Let's take a look at this next one here. I've got 4 sine squared of x equals 1. There's two different ways to solve this, just in the same way that there would be two different ways to solve 4x squared equals 1, right? I could divide both sides by 4 and take the square root, which I think is probably the easier way, right? So we'll end up with sine squared equals 1/4. I would then take the square root of both sides. So the square root of sine squared is just sine of x. But now, the square root of 1/4, whenever we take the square root, we can't forget our plus or minus. Okay? Square root of 1/4 would be plus or minus 1/2. Now, real quick, let me just talk about the other way we could have solved this to get to this point. Right? I could subtract the 1 over here, 4x squared minus 1 equals 0, and then this is a difference of squares. So this would actually factor into 2x plus 1 times 2x minus 1. Okay, then that would really be 2 times sine of x plus 1 times 2 times sine of x minus 1. Solve each of those factors, and we would get sine of x equals positive 1/2 and sine of x equals negative 1/2. Okay? So now, this is really, like I just said, we've got sine of x equals negative 1/2 and sine of x equals positive 1/2. Okay? I'm looking for any values on the unit circle where sine is negative 1/2, so the y value of negative 1/2 shows up here and here. That would be 7 pi over 6 and 11 pi over 6. And then sine is positive 1/2 here and here at pi over 6 and 5 pi over 6. Okay, and yet again, because we're just looking on the interval 0 to 2 pi, I am not including my plus 2 pi n on these values, okay? In the final example, under example 1, we actually have a function that's got two different trig values, okay? Now, this factoring and solving a quadratic that we've been doing only works if we have the same trig function, right? Just in the same way that I can only solve a quadratic that has one variable. I can only solve a quadratic trig equation that has one trig function. So what we're going to do here is use our Pythagorean identities, okay, to substitute and get these all to be the same trig value. Now, we are always going to be working with whatever the squared value is. That's the one that we want to change into the linear function, okay, the one that has a power of 1. So I want to change sine squared and make it into cosine squared somehow. Well, we're going to use our Pythagorean identity, which is sine squared plus cosine squared equals 1? Well, I can say that sine squared is equal to, I can subtract the cosine squared over and say that sine squared equals 1 minus cosine squared. Okay, so that's what I'm going to do. I'm going to substitute 1 minus cosine squared in place of sine squared. Distribute the 2 through, and we'll have 2 minus 2 cosine squared of x plus the square root of 3 cosine of x plus 1. Well, I've got a 2 and a 1. Those are like terms. I can go ahead and combine those. So negative 2 cosine squared of x plus the square root of 3 cosine of x plus 3 equals 0. Now, whenever we're working with a quadratic, it's usually easiest if my leading coefficient is positive. So I can go ahead and divide both sides here by negative 1. All that's going to do is change the sign on every term. So I can go ahead and make this 2 cosine squared of x minus the square root of 3 cosine of x minus 3 equals 0. Okay, so now we would want to solve this quadratic. We could try to factor, but my b value is a square root. That's going to be really difficult, if not impossible, to actually factor. So our other foolproof way of solving a quadratic is to use the quadratic formula. Right? We can do that in this case. Right? The 2 is my a value. Right? The negative square root of 3 is my b value, and then the negative 3 is my c value. So we're just going to use the quadratic formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And if we plug these values in, the opposite of the square root of 3 would be positive square root of 3 plus or minus the square root of negative square root of 3 squared minus 4 times 2 times negative 3 all over 2 times a. And we can simplify this. Right? This would become the square root of 3 plus or minus. Now on the inside here, negative square root of 3 squared would just be 3. Then plus, because I've got a double negative, 4 times 2 is 8, times 3 is 24. So we've got 3 plus 24 on the inside here. That would be 27 all over 4. And I can actually simplify this radical a little bit and make this, I can simplify, here, I'll do it off to the side here, this square root of 27. If I look for the largest perfect square that divides evenly, that would be 9, right? So I can actually make this 3 times the square root of 3. So I've got the square root of 3 plus or minus 3 times the square root of 3 all over 4, right? Now, I did not write down what this was all equal to over here. Usually, if we're solving a quadratic, we would just write x equals, right? But in this case, my x, whatever this function is actually cosine. So I'm going to say cosine of x equals this. Okay, so what we end up with all the way down here is that cosine of x has 2 possibilities, right? We can say that cosine of x equals the square root of 3 minus 3 radical 3 over 4, or we can say that the cosine of x equals radical 3 plus 3 radical 3 over 4. So here, if I've got 1 radical 3 minus 3 radical 3, that would be negative 2 radical 3. I can then simplify negative 2 over 4 would reduce to negative 1 over 2. So this would just become negative square root of 3 over 2. And now we've got cosine equals negative square root of 3 over 2. I can go to my unit circle and see where the x value, the cosine, is negative square root of 3 over 2. That happens here and here at 5 pi over 6 and 7 pi over 6. All right, so here, this yields two answers, 5 pi over 6 and 7 pi over 6. All right, and again, we are just looking for values in between 0 and 2 pi, so I do not need to tack on my plus 2 pi ends here. Now for this one, 1 square root of 3 plus 3 square roots of 3 would be 4 square roots of 3 over 4. The 4's would cancel, and this would just be square root of 3. Now, square root of 3 is not in the range of cosine, right? Cosine's largest value is 1, smallest value is negative 1. The square root of 3 is greater than 1, so this piece yields no solutions. So I only get two answers here, 5 pi over 6 and 7 pi over 6. Right? This was certainly a longer one, especially since it wouldn't factor. Right? We had to use the quadratic formula here. But the initial part, right, kind of the big part of this problem was understanding that we can use a Pythagorean identity to write this function in terms of the same trig function. All right? Let's do one more example here. Okay? In this one, it says we need to find all solutions by first squaring both sides. Okay? So the first thing I'm going to do is square both sides of this equation. Okay? Well, over here, I just have one term, right? So I need to square, and by one term, right, I mean everything's being multiplied. So technically, this is all one term. So if I square the square root of 3, that would just be 3. And if I square cosine, that's cosine squared. Over here, then, we need to be careful. Since I'm adding, I need to essentially, right, this is sine of theta plus 1 times sine of theta plus 1. So I need to multiply this out. I can't just distribute this square. So this would end up being sine squared of theta, then sine times 1 is sine, plus sine times 1 would be 2 sine of theta, and then 1 times 1 would be 1. So now, just like in the last problem, I have two different trig functions present here. Okay? I want to write everything in terms of just one. Well, to choose that one, I want to look at the linear term. Okay, that is a sine. So what that tells me, I want to change my cosine squared into sine squared. Right? So I can say that cosine squared is equal to 1 minus sine squared. Right? And that comes from our Pythagorean identity. Distribute the 3. We'll have 3 minus 3 sine squared of theta equals sine squared plus 2 sine of theta plus 1. So now I just want to get everything on one side equal to 0. Okay? So let's see, I can subtract the 3 over and then add 3 sine squared. So if I do that, that would be 4 sine squared of theta plus 2 sine of theta. And then if I'm subtracting the 3 over, 1 minus 3 would be negative 2. Now, we don't have to do this step, but I see that every coefficient and every constant is divisible by 2. So just to make the arithmetic a little bit easier, I can go ahead and divide both sides by 2 and just make this 2 sine squared of theta plus sine of theta minus 1. Then I can try to factor this. Right? I think this one will factor. Right? So I'll come off to the side here and say that this is 2x squared plus x minus 1. So I'm looking for two numbers that multiply to -2 that add to +1. I think that would be 2 and -1. So I can split up my x and make this 2x squared plus 2x minus 1. Group the first two. I could take a 2x out of those, and I would be left with x plus 1. And here I can take a -1 out of these, and I would be left with x plus 1. So this factors as 2x minus 1 times x plus 1. So that's what this will look like here. Right? I will have 2 times sine of theta minus 1 times sine of theta plus 1. Set each of these equal to 0. And solve. Here I would add 1 and divide by 2. So we'll get sine of theta equals 1/2 on the unit circle. That occurs here and here. So here I would get theta equals pi over 6 and 5 pi over 6. Then for the second part, subtract the 1 over. We'll get sine of theta equals -1. Well, that occurs here at 3 pi over 2. Okay? Now, there is actually one extra step to this problem. Whenever we square both sides of an equation, or technically raise both sides to any even power, we could introduce extraneous solutions. Okay? So whenever we square both sides, we need to check for extraneous solutions. That just means I need to take each of these values and plug them into my original equation, right, without the square. So if we start with pi over 6, we would have the square root of 3 times the cosine of pi over 6, and we want to check to see if that is equal to the sine of pi over 6 plus 1. Well, cosine of pi over 6 is the square root of 3 over 2. Sine of pi over 6 is 1/2. So the square root of 3 times the square root of 3 would just be 3. So we get 3 over 2. 1/2 plus 1 would be 1.5, or 3/2. This checks out. Right? So pi over 6 is a solution. All right, let's check 5 pi over 6. So again, we have to go through the same process. Square root of 3 times the cosine of 5 pi over 6. We want to see if that is equal to the sine of 5 pi over 6 plus 1. Well, the cosine of 5 pi over 6 is negative square root of 3 over 2. The sine of 5 pi over 6 is 1/2. So here we would end up with negative 3/2. Here we would end up with positive 3/2. Those are not equal. That means that 5 pi over 6 is an extraneous solution. Right? That is not one of my answers. Then let's check 3 pi over 2. So again, same thing. Square root of 3 times the cosine of 3 pi over 2. And we want to see if that equals the sine of 3 pi over 2 plus 1. So the cosine of 3 pi over 2 is 0. And the sign of 3 pi over 2 is -1. So we get 0 over here equals -1 plus 1 is 0. That works. So that means that 3 pi over 2 is one of my answers. So in this case, we only have two answers, pi over 6 and 3 pi over 2. Okay, so very similar process, except we need to remember to check for extraneous solutions if we are squaring both sides of the equation. Okay, so that is it for this video. The final question is going to pop up asking you what questions you have.